How's about another exciting episode of Kitchen Table Electronics Repair with uxwbill? Only because my mother is making Easter dinner downstairs in the kitchen, I'm going to do this on my desk. What I have here is something that was given to me by a contractor who was doing some work for my employer. This is a Tripp-Lite power verter 7 amp. It's a model PR7B. They still sell something very much like this today. In fact, they sell several of these in several differing capacities. And I'd like to give a big shout out to the nice people at Tripp-Lite who oh so politely refused my request for a schematic. Oh well, it's not the first thing I've had to repair without the help of one, and it surely won't be the last. But you can see, even with this thing turned on, and amazingly the neon light in the switch still works perfectly, there is absolutely no output. Not even AC output. Just nothing at all. It's just dead to the world. Starts up, hasn't blown its fuse, but it's got absolutely no output. So let's dig into this thing and see what's going on with it. Now, it'll come as no great surprise to anybody who watches my channel regularly to know that I've already been inside this thing. And I've taken a look at it, tested most of the parts on this little circuit board over here that makes up the regulation and all that good stuff. And everything on here tests like it should, which leads me to believe that maybe that controller IC down there, which is a UA723, has quite possibly gone bad. And I have a couple of reasons for thinking that. You know, it's good to develop a hypothesis when you're working on repairing something. I know that this thing was being used to test a security camera that was already in a bad way. And so my thought is that, you know, with the problems that security camera had, that maybe it caused this thing to fail. The reason being that this thing says right here, electronic overload protection with instant automatic reset. Well, I looked into how they're doing this, and really, if I've understood the circuit properly, and I think that I have, it seems that the only thing that protects this thing is the current limiting built into the regulator itself. So I envision that if somebody inadvertently shorts the output of this thing back here, that the regulator is going to do the electronic equivalent of saying, "Stop that! Stop it!" and just wait until things have cleared up. But I would imagine that if you do that enough, you might eventually end up killing the regulator. Now, the regulation in this thing actually happens in two separate places primarily. You have the little UA723 regulator down here, and then you have these two transistors on the back, and these are called pass transistors, and they actually supplement functionality that's built into the IC. The regulator IC itself has a built-in set of pass transistors, but they aren't good for nearly 7 amps worth of current delivery, so these outboard pass transistors are used instead to increase the current delivering ability of the regulator in this particular circuit. And so my theory is that the regulator in this thing has gone bad. So what I have here are some replacement UA723 regulators. I just need to get in there with ye old desoldering iron, pop the old regulator out. It's a 14-pin part, shouldn't be too hard. Pop a new regulator in and see if this thing works afterwards. If I'd have been the designer of this power supply, I think I'd have gone about implementing the protection differently. I think I would have used something to cause the protection to latch in a shutdown state, as opposed to simply bouncing back after the short circuit has been removed. Something that would require the user to alleviate the problem rather than sit there and continue to abuse this poor and now dead regulator chip repeatedly until the problem is addressed. There it is. One replacement voltage regulator has now been installed. We'll go ahead and do a test on this thing and see if it works like it should now. Alright, got the meter hooked up here, got the new controller chip in place, the new regulator chip. Let's see what happens here. Look at that. Beautiful. A little bit high on the voltage, but I don't know how tightly regulated these things are. I just have to get myself a load and hook it up and see if this thing will drive it like it ought to. But there it is, happily running again. I'll give it a bench test for a few hours, maybe driving a dummy load made of resistors or something to see if it's really fixed for sure, but I think that's got it. This would be a nice little power supply to use for something, maybe run a car radio off of it or something like that. Should be plenty useful enough. I happened to notice this just now. When I turned it off, I left the voltmeter connected to watch how fast the output decayed to 0. Now this thing dates from 1985. Most of the components in here have early to mid-1984 date codes on them, and the serial number, according to Tripp-Lite, which they did help me decode, although it didn't exactly take a rocket scientist to do it, indicates that this thing was manufactured in early 1985. So it's definitely had some time and age on it. But it seems even so, all these years later, the output filtering capacitors are still in pretty good shape, because it takes this thing's output a long time to decay all the way to zero. I would say it's pretty stable.
Donald Trump doesn't need Google, he owns a mirror. I mean, who? So, where are you, Mr. Zuckerberg?
This one will probably be my next project. It too has no output whatsoever when it's turned on, and I would imagine that much the same thing is wrong with it. The only drawback being it's got these stupid square head screws holding it on, and well, I know I've got a square head screwdriver someplace. I don't know where that place is.